Hey guys, welcome to another chemistry lesson with Mr. Shower. Today we're going to cover balancing and go over a few examples for each different scenario you're going to kind of encounter. Okay, we're going to go over the basic ones today. Alright, so let's take a look here. Alright, so balancing examples. First thing is we're going to be using coefficients to balance each equation. And by balance, we mean making each side have the same number of elements, which entails both sides having the same mass. So left side will equal the right side as far as the count of elements. And based on the element's mass, okay, if we add up the left side's mass and we add up the right side's mass, they should be equal. Okay, so let's start out with this example here. What we have is potassium plus chlorine. Okay, potassium's a solid, chlorine's a gas, and we're going to get potassium chloride solid. Now, what I did and how I learned was to make two columns. Okay, you can do one column down the middle, which I've seen, which is pretty cool as well. All right, so to balance this, we want to make the left side equal to the right side. So on the left side, we're going to tabulate the amount of each element. So on the left side, we have 1 potassium. On the right side, we have 1 potassium. So that's already balanced. Now on the left side, we have 2 chlorines. On the right side, we have 1 chlorine. So the chlorines are not balanced. Now, based on math principles, we're going to put a coefficient of a 2 right here. Now, why am I putting a 2 right there? Well, the 2 gets multiplied to the chlorine and to the potassium. So it's going to change our chlorine count now to a 2. Okay? Now, you can only put a number on this line right before the compound. Can't put it in between. So this 2 is going to adversely affect the potassium count by making that a 2 as well. Now, if you look to the left side, the chlorines are good now. It's reversed. Chlorines are not good anymore. So that's pretty simple. So we can just say chlorines by itself, and we can place a 2 right there, which gives us our final count of being a 2. So tabulating the quantity of elements you have in the bottom here is very important. Okay? It helps you out. Now, the next problem, let's take a look. Okay? We have aluminum plus oxygen, all right, yields aluminum oxide. So here we're going to tabulate, okay, we're going to aluminums and oxygens. Let's go over the quantity of each element. On the left side, we have 1 aluminum and 2, sorry for my math, sloppy, and we have 2 aluminums, okay, and then we have 3 oxygens. All right, so we have a complete difference in the quantity of elements that are present. Now, which one do we start with? Well, there's a little rule I follow. I go CHO. Balance any carbons? No. Balance any hydrogens? No. Then we go with oxygens. Perfect. Now we could start with aluminum or we could start with oxygen. So I'm going to start with oxygen based off the CHO. And after O's, doesn't really matter which one you start with. So I'm going to go with the O's, making them balance. Now, if you have 3 oxygens here and 2 oxygens there, least common multiple is going to be 6. So we can make both of these a 6 by placing a coefficient in front of the compound of a 2 for this one. So we're going to make oxygen on the right have 6. And then it's also going to change the number of aluminums to 4. Okay? Remember, the 2 goes to the oxygen and to the aluminum. So on the opposite side, we're going to fix the O's as well. So we're going to place a 3 there, which is going to change the number of oxygens to 6. Okay? Now we have aluminum by itself, and it has a 1. Over here it has a 4. So we can simply place a 4 right there. So now we have 4 aluminums and 6 oxygens. So technically it is balanced. Okay, so your coefficients are 4, 3, 2. Okay. Next problem deals with polyatomic ions. Okay, polyatomic ions are a very important group of ions. If you see a polyatomic ion, you got to stop for 1 second. Okay, so if a polyatomic ion is present on both sides, it can act as a unit. What do I mean by that? Well, if you have a Cl on one side and a Cl on the other, they act as like a unit. Okay, so if you have any of these polyatomic ions, okay, we learned this in the naming chapter. So you have your ions with the -1 charge here, -1 charge here, and your ions with the -2 charge, and your ions with the -3 charge. The charge number right now doesn't matter with the balancing. What matters is the formula, BrO2, ClO3, IO4. You have to have the sheet out in front of you unless you've been doing this for a long time and you know all of them. OH, CN, SO4, okay? And then you have your phosphates, which are very common and popular. So your phosphates, PO4, PO3. Okay, your sulfates and sulfites, SO3, SO4, and your nitrates, nitrites. Okay, these are very common. These are most popular ones that we end up using. Okay, so be familiar with a polyatomic ion. It's basically 2 or more elements put together in a balanced equation. If you see one on one side and it's present on the other side, you can actually just balance the polyatomic ion as a unit. You do not have to separate them. You can separate them, it just takes a lot more work. Okay, so let's look at the first problem here. Okay, the first problem, as you notice, here we have potassium phosphate, PO4, HCl plus KCl plus H3PO4. So we have a PO4 on this side, and we have a PO4 on this side. Okay. Now, I realized in the list right here, change this to 4. Okay, phosphate, phosphate. Okay, so we want to begin by balancing. First thing is to look to see how many of each element there are. So let's do it here. We have 3 potassiums, 1 phosphate, 1 hydrogen, and 1 chlorine. On the right side, we have 1 K. Over here, we have 1 phosphate, 3 hydrogens, and 1 Cl. Okay, so let's begin the balance here. You have your phosphate. You don't have to write P by itself or O by itself. You leave it as it is. Okay. So, which one are we going to start with? Carbon? No. Hydrogen? Yes, we have a hydrogen. Remember your CHO. Okay, so your H is a 1, H is a 3. So what I'm going to do is I'm going to put a 3 up here. Okay, which makes this 3. But it also changes the number of CLs, because the 3 goes to here, and the 3 goes to there. Alright? So our CL will be 3 as well. Okay? Now on the right side, we have to modify it as well. So we have our H's that are good now, and our CLs which have a 1. But we have to make the CL a 3. So I'm going to put a 3 right here, which makes your chlorine a 3. Okay? Remember, it goes to the Cl and it goes to the K. So we're going to change the K to a 3. Okay? Wow, it actually balanced itself out. So we have 3 Ks, 1 PO4, 3 H's, 3 Cl's. Balanced. So your coefficient is 1, 3, 3, 1. Not too bad. Okay, last example. We have PbNO3, so that's lead 2 nitrate, plus sodium iodide, NaI, yielding or producing lead 2 iodide plus sodium nitrate. Okay? So we want to make our list of the elements that are present. And look at that. We have a nitrate on the left side and a nitrate on the right side. So we can balance it as a unit. Okay? You can balance them individually with an N and an O, but it's a little more drawn out. Okay, so let's look. Let's draw the number of elements for each one here. We have lead has 1. Nitrate has 2. Outside of the bracket, there's a 2. So there's 2 nitrates. Okay, the subscript. 1 Na and 1 I. Kind of stuff. Lead is 1 on this side. Nitrate, there's only 1 NO3. Okay, this 3 belongs to the NO3. Okay, Na is 1. And I is 2. Okay? Now, looking at this here, it's not too bad. We have a difference of 2 nitrates on the one side and 1 nitrate on the other side. 1 iodine on one side and 2 on the other. So let's balance the nitrates first. Okay? So we want to place a 2 here, all right, to make the nitrates equal. All right, so there's 2 nitrates, which also means the 2 goes to the Na. So we have to fix everything as we go. All right, so now we go to the left side. We want to balance the sodiums and the iodides. So I'm going to place a 2 right here, which fixes the balancing of the sodium and the iodide, like so. Perfect. So it's balanced. The left side equals the right side. So we have 1, 2, 1, 2 for our coefficients. Okay. Do is to balance this one equation right here. Okay, write it down. Pause it. Okay, write your itemized list of the elements below. Okay, so pause right now. Okay, now you should have your equation balanced or attempted to balance. Okay, so your list looks like this. And after you balance, you should get 2, 3, 6, 1. Guys, so in this case, this is a problem. Depending upon where you start, I chose to start with DE, and it worked out. This one is a little step up. This is a medium difficulty one. I wanted to give you one to see if you can do it and challenge yourself. Okay, not all these problems are super hard. Some are very simple, like I showed you, and some can get a little tricky. But this is like a medium hard problem here, this one here. So if you can do this one, no problem, you're looking good for the future. If you had some issues with it, just go back and watch the video again, tally them up, look for the proper coefficients and how you distribute that number through is usually one of the biggest problems. All right, guys, I want you to hit subscribe and like for me. Till next time.
See you later.